And there it is. You can see a low stratus layer about 900 feet off the ground developing across much of Texas. And that's associated with that first burst of cold air slipping southward, and with very strong modification of that humid air mass that results in very quick cloud development. And there it is on our surface mesoanalysis. 31 degrees at DFW with a 500-foot ceiling, 42 at Austin, but you can see there in West Texas, it really depends on where you are. The cold front running from about Sanderson, Dryden, all the way up to Roswell and back towards Santa Rosa, New Mexico. Some impressive temperature differences. 74 degrees there at Marfa, contrasting with 31 at Midland. 67 up at Guadalupe Peak. You could be having a picnic up there this afternoon, but a little ways to the east, 37. And even down there in the Rio Grande Valley, almost 80 degrees, and yeah, even 86 there, just south of Laredo. Those kinds of extreme temperature differences are really what makes weather so interesting in this part of the world. I forecasted for about a year in Korea, about 3 months in Kenya, and never saw anything like what we see here in the U.S. Here's what we have this afternoon. That front has, well, here's that piece down here that's been in place along the Gulf Coast for a couple of days, but the colder air coming down through Arkansas into Tennessee, and the strongest piece of it now flooding into Texas. A similar thing going on in the northwestern U.S., the old polar front boundary, through the Snake River Valley back towards Salem. However, the stronger cold front located up here, entering Vancouver, possibly northern Seattle, and definitely coming into those valleys in eastern Washington. You can see that the air mass across the southwestern U.S. is fairly mild for this time of year. Not much going on there, and so I've referred to that as a continental tropical air mass, but more of one we would see during the wintertime. That mild air extends into the Intermountain region and valleys of Colorado. Temperatures there, 40s and 50s, but you can see much, much colder just to the east. And then looking up there in Canada, yep, it's still cold. Minus 20s to minus 30s. Very similar to what we had yesterday, except it is spreading south into the northern Great Plains. At this hour, minus 3 at Bismarck, 5 above in Minneapolis, and it's likely just going to keep getting colder. Up in the high Arctic, here's how things look. We'll bring this all the way up to Alaska. Don't see any minus 50s. And a massive warming trend there at Eagle, Alaska, from minus 51 yesterday up to minus 1 today. Here you can check it out for yourself. This is Eagle, Alaska, going backwards in time to yesterday. And yesterday morning, 17Z, we had minus 46 Celsius, which is minus 51 Fahrenheit, and they warmed on up to minus 16 Celsius, which is actually 3 above Fahrenheit. And that tells me that the Arctic air was probably pretty shallow in those areas, maybe confined primarily to the valleys. The minus 20s are looking like this. One large piece of it up there in Alaska, Yukon, all the way down to British Columbia, and another piece of it across the Canadian prairies. So it has moderated up in the high Arctic region. But man, you can see some of the more impressive temperatures are found down to the south. Yes, let's take a little trip, working our way down the frontal boundary, starting with Alaska. Let's see what's going on there. This is a great way to examine the air masses. It is cold up there, but not excessively cold. You can see the temperatures, 30s and 20s. That's pretty mild for Alaska, but some flow coming from the interior regions around Anchorage. we work our way down to the southeast. Temperatures are cold there. Wrangell, Alaska there in southeast Alaska, getting gusty east winds through the passes. And that's bringing temperatures down into the teens in those areas. Going further down the British Columbia coast, Prince George and some of the areas just inland, those are all showing cold air from the interior regions blowing through the passes out into the Pacific Ocean. And when you see temperatures in the 20s this far off the coast, that means that there's a lot of air mass modification taking place, probably stormy, some lake effect type snows there over the oceans. And that can help feed into the baroclinicity of storms that are off in the Gulf of Alaska and help intensify them. Further southeast, well, we talked about that frontal boundary, and the strongest boundary runs about like that. And you can see that the cold air has not really reached Missoula, Montana. That's 20, that's not really cold, like it is at Great Falls where it's minus 11. So a lot of the stronger, richer, denser cold air is being held east of the Continental Divide. However, we can see that some of it is forming up to the north in the Canadian valleys right there. See, it's minus 13 right there. So eventually, if this cold air mass production does continue, that will filter down into Washington. Further to the southeast, some pretty dynamic weather conditions there in southern Wyoming. Rawlins, Wyoming, 30 knots gusting to 45. Well, that's not air back behind the cold front. That's actually air from the interior regions of the Great Basin. So let me draw that front for you. So the front is running something like that right there. And as you can imagine, these winds are flowing up and over the cold dome. And that's helping to produce some lift, some clouds and snow showers back east of the front. And further south, we've covered some of that area already. We know that the frontal boundary is down through South Texas, running about like that. Looks like it is maybe not just past Del Rio yet, but it is passing Roswell, has passed Santa Rosa, and it is all the way through Raton and back towards the Continental Divide. And some very warm temperatures west of that boundary. Lots of 70s there in Texas, and as we saw, 80s down in the Rio Grande Valley. And then a quick look out in the southeastern U.S. Yeah, it looks like we've had some air mass recovery in the southeast, because I'm seeing 70 degrees right there south of Nashville. So I think this frontal boundary up to the north is actually strengthening a bit, and we've got to bring that kind of like this here. So that appears to be the stronger front at this time. Looks like some cold air damming in Virginia and North Carolina. So I've got to bring that front through roughly like that. That's going to call for maybe a little bit of adjustment in the surface analysis. So that other boundary down to the south, it is there, but it is not as significant as the northern one at this time. So based on everything that we're seeing here, I think the frontal positions are looking something like this. So this is still an open wave up in Tennessee, but that could always be a possible region for further development. And that concludes our trip around the U.S., sponsored by Okay, we got to have a little bit of fun, so we'll just kind of leave it at that. Anyway, the big story is next week. This is the forecast temperatures by the GFS model. This is not wind chill. This is actual temperatures Tuesday morning. Look at that. They've got 0 all the way down to Austin, down to the woodlands near Houston, and all the way into Mississippi. Now, this is a pretty extreme example. However, one of the rules of forecasting is you never forecast extreme conditions unless you're dead certain. However, let's take a look at the forecast run progression. So we're going to look at the same time on Tuesday morning, but go back through previous runs about 2 days ago. And you can see how things evolve and what kind of consistency we're getting from this model. So this is the model run from Sunday night. And if we bring this forward, you can see a cooling trend in this model, maybe a little bit of flip-flopping here and there. But as we get into yesterday's model, it kind of locks in this scenario. And that's where we're at right now. And you can see going back to last night and going back to this midday hour, it's very, very similar. So the GFS has kind of converged on the solution, but we're still about 138 hours out. Now, the European model has a much less severe picture. So there's the temperatures Tuesday morning, and they've got 3 degrees in Dallas. That's still pretty cold, and minus 12 in Oklahoma City. How's the consistency of the European model? Let's run that back all the way to Saturday. So there's what it was forecasting back on Saturday for Tuesday next week. And we can see it's flip-flopping quite a bit. And then finally, overnight into today, we've got a little bit of stability in the solution. So it's certainly forecasting very cold temperatures, but we still have a little ways to go. So I kind of expect maybe there will be some changes between now and the weekend. But this certainly bears watching. Why is it so cold? Well, take a look at snowfall. This is what it forecasted back on Saturday's run for next Tuesday. And we're going to go forward through the runs. So it kind of dries things out with the model runs earlier this week. And then suddenly, snowstorm in Texas. And it's kind of converging on this solution of a lot of snow in North Texas. So that's obviously going to produce quite a bit of cold air by insulating the air mass. And when we get the lift and the adiabatic cooling of some of this air, that's going to help cool it further. And also the cold advection from the north from fresh cold air oozing southward. So that's the reason this model, or all of these models, are going so severe. And the warmest model is actually the UK Met. And there's what it's got for snowfall, looking at the UK model. So it's also going for a snow event. Well, the UK Met does not go out past 144 hours. However, the scenario that it's painting for Monday evening is definitely brutal cold. 7 in Dallas, minus 1 in Oklahoma City, and this is the warm model. Now, I'm not entirely sure that any of these scenarios are going to play out. These are all extreme scenarios, and like I said, we don't forecast extreme weather events unless we're certain. However, the UK Met is the warm model, so that does pose a little bit of concern in my mind. So why is there so much uncertainty in the models? Well, let's take a look at the hemispheric map. Well, here's the wave associated with some of the cold air on Tuesday, and let's back this up and see where this wave is right at this moment. Okay, did you track that? It looks like those waves are still over Japan and maybe China. And we roll that forward, and you can see them emerging out in the Pacific and then gradually heading for the U.S. So obviously a lot can change between now and then, and it's kind of a wonder that these models work as well as they do. So that shows you that there's still a lot of uncertainty between now and next week, and we're just going to have to wait a few days. But I still like picking apart these models because I like to see how they come up with these extreme solutions, and that gives me some insight into what might have happened during those incredible events of 1899 when the temperatures did get that cold. And if I see those patterns emerging in the models, then maybe I'll be able to spot them in the data early on. Now, this is an interesting graphic I wanted to show you. This is a cross-section running from south of Tucson across Texas into Alabama. Now, this is theta E. This is not exactly what we would use for cross-sections. However, it does work fairly well when there's cold, dry air in the low levels. And what we can see here is the top of the cold air mass running about like that. These tops are at about 5,000 feet MSL. And you can see that they don't really go very far back into the higher terrain of the southwestern U.S. And here's what it looks like with the true theta, the true potential temperature. This goes all the way up to 100 millibars, so it's kind of hard to pick out these low-level features because things are more squashed. But we can run this forward into tomorrow and into Friday and Saturday, and you can see that cold air down here, see how the lines are kind of dashed? This is actually the wind component coming from the east. This is northeasterly flow down in the cold air, and above that this is westerly flow, and higher up you can see the jet. So this is a great way to see the cold air building and sloshing back and forth. And you can see towards the weekend, things are getting quite active out there around the Continental Divide region. A lot of lift working on that area, a lot of easterly flow pulling that cold air upslope. And you can see things get pretty busy out in that region. Very strong easterly component develops in that area late in the day on the 14th. And then the whole disturbance passes off to the east. And behind it, looks like the model's going for some cold air down across the plains of Texas. And eventually that modifies, and we're not going to worry too much about what happens after that. So I think that's all I want to cover. Hopefully that gives you some interesting things to think about. So head to these model sites and see what you can find. And I want to thank our new supporter, Jay Coley. Thank you for supporting the webcast. All right, that'll do it for this edition of Forecast Lab. Thank you for watching, and we'll see you tomorrow. Bye-bye.